the Ring Silencer app. Now, I know we looked at some different apps on code.org, and the apps were rather basic in nature, right? They were simple. They were really, really simple, and that's okay. Because an app doesn't need to be complicated to be able to solve a problem, right? Even the most simplest of apps can solve problems in our lives. So, like this one, we're going to think through this one here. It's called the Ring Silencer app. Now, have you guys ever had your phone like ring in class or like beep in class or something like that? Has anyone ever had that happen? Okay. You forget to turn it off when you're in school, right? It's a manual process that we have to take. Well, wouldn't it be nice if we had an app that figures out when the phone is at school so we actually don't need to remember to manually turn it off? It just automatically does it for us, right? One less thing we have to think about. So that's what we're going to think through in this app. So right off the bat, we know that this app is going to solve a problem for us, right? So when the app is working correctly, what type of output should the app produce? What should it do? What's the end goal of this app? So so what does this a successful app do? We want the phone to be silenced when we're where? Mason? Yes. So we want the phone to be silenced when are at school. So that's all we want. That's all the app needs to do to be successful. It's a pretty basic app. Okay, so now we need to figure out with this prepare section here, right here, we need to figure out what information the app needs in order to be successful. Can you guys see my screen okay? All right. Okay, so what type of information do we need? So it fills in the first one for us. It tells us that we need the app needs to know your location, right? The app needs to know your location. And it knows this through a phone sensor. And do we need to store it for later? Probably not, because why would we not store that? We talked about this last week on the storage assignment. Why would we not store your location in this app? What do you think? Josh, any ideas? You're always moving, right? You're always moving. Think of the type of data or the type of storage space you would need to have on your phone if we were always tracking every single place you went, right? Because you're at home, you're on the bus, you're at school, you're in the cafeteria, you're in different classrooms, you're in how many different locations a day, right? 20, 30. Um, so we don't need the app to store that. So it needs to know your location. And since we're determining, we're going to silence your phone when you're at school, what else does the app need to know? It needs to know your location, and it also needs to know what else? The location of where? The school. Very good. So it needs to know um, the location of the school. Whoops. The location of the school. Okay, so the app knows two things. It's a simple app, right? Two inputs. It knows your location and the location of the school. Now, how would an app, based on a lot of the things we've seen in code.org, how do apps know the locations of things and like show us maps and everything? Where does it get that information? It doesn't get it from GPS. Where does it get that information? So remember, apps use the internet just as much as humans do, right? So it gets that information from the internet. Okay. Apps use the internet just like we do. So it gets the location of the school from the internet. And what do you guys think? How many people think we should store this for later? Yep, you're right. We absolutely should, because we don't want to be looking this up each time. That's the whole purpose of the app, right? The whole purpose of the app is to silence your phone when you are in school. So, of course, we want it to remember the location of the school. Um, what type of processing do you think this app is going to use? There's only one main one. What type of processing? Remember we looked at different types of processing last week. If then, counting, finding a match, and comparing. Well, it's actually using two different ones. What's one? What's one? Mason, what do you think? What's one type of processing we're going to use here? Yep, you are totally right. So if then, because you know, if the phone is at school, then what's going to happen? It silences. So if then, and then the other type of processing it's going to use is comparing. And what are the two things it's going to be comparing? Anyone know? Laura? Very good. So it's going to be comparing your location in the location of the school. So does that make sense, guys? That's how the app's going to be thinking constantly. When you have this app on your phone, it's going to be constantly doing this processing with if then and comparing. So when these two things are at the same location and they're compared and they're the same, then the phone is going to silence. Now let's draw a little simple algorithm here, um, just to kind of like think through how the app is going to work. And you will need to do this for your project. So this is going to be like your practice for the project. Um, so let's just kind of think, through a day in your life, okay? So let's just pretend, and I'm just drawing like a little box in here. You guys can follow with me here. Okay, so so we're doing, if then type of processing, right? What's the first question the app is going to ask itself? What's the first question the app, Mason? Yeah, are you at, whoops. So is the phone at school? I should have made my box bigger here. Jeez. I wonder if I could do that. I'm still learning how to use this text app. So you guys, I just, thought it would be easier since I can't write on my board. Typically as of last year, my TV was over there in front of um that green chalkboard, and I was able to write on my marker board. So now I'm doing it this way. Okay. So is the phone at school? So it either is or it isn't, right? So let's think through what happens when it is or when it isn't. Okay. So I'm just drawing like a simple line here. So it either is or it isn't. Oops. Okay, I don't know what is going on there. App is not cooperating with me this morning. Okay, let's just not draw right now. Okay, so if the app is at school, yes, and then, oh, okay, I should be using a vertical line there. Learning on a Monday morning, right? Okay, so the app is either at school or it's not at school. What do we want to happen um, when, well, you know what? Instead of asking if we're at school first, well, no, let's go with this. I like this. I like this processing here. So, is the phone at school? Yes or no? Okay, what do we want to happen when the phone is at school? Serenity, what do we want to happen when the phone is at school? Yes, exactly. So, we're going to tell the app to silence ringer. Okay, silence ringer. And if it's not at school, what does the app do? The app does nothing, right? We don't want the app to do anything. So we say do nothing, okay? And this is how your apps think, you know? So is the phone at school? Yes, silence the ringer. And if it's not, then do nothing, okay? All right, so that's just kind of like our basic thought process here when it's comparing, your location to the phone's location, okay? Um, and it's that simple. All right, so let's actually run this algorithm as if it's today, you know? Now some of you guys who are watching from home will have a different answer for try. But if you're in school today and you're doing this assignment with me, you'll have a totally different answer for try. So let's run this algorithm as if we're in school. Is your phone at school? Yes. So we're going to silence the ringer. Okay. Now, this is a really basic algorithm, right? Really basic algorithm. But that's okay. Algorithms don't have to be complicated. So, yes, we're going to silence the ringer. All right. So that means the app is working, right? Because the output here matches what we put up here and define. And this is a key part of the project, guys. Whenever you guys do the project and you draw your algorithm for the project, whatever you get to as the last step of your algorithm has to match what you put under define, or else the app's not working properly, right? And you're not going to have a successful app if you can't think through the steps how to get there. We're actually going to build onto this algorithm here after we reflect a little bit. So does everything make sense so far, guys? Okay, thank you. All right. So the app turns off the ringer even when the user is not in class. So think of it this way. You're down at lunch, you want to get notifications on your phone. You want to be able to hear it. It's noisy. You want to be able to hear it when you're walking through the halls in class, right? We only really want this phone to be silenced when you are in class. So a better version would not only turn off the ringer at school, um, but would also know when the user is quiet and not moving. Okay. So if the user is moving around or making a lot of noise, it would assume it's not class time and keep the ringer on. So how could we think this through? How could we think this through? What does the app need to know if we want to do this? It needs to know a couple more things in order to get this done. So the app needs to know two things. We're basing it on noise and movement, right? noise and movement. These are two sensors on your phone. Your phone knows when it's moving, right? It knows when there's noise, right? It can pick up noise. Okay, so what does the phone need to know? It needs to know movement. How does the phone know that you're moving? You ever thought about that? It keeps track of your steps, right? If you go into the health app, it keeps track of your steps. Not sure how accurate it is, but it does that through a sensor. And it's a movement sensor. Okay, hold on one sec. Sorry, Shelby, I'll be right back. All right, guys. Sorry about that, guys. Um, so so it knows movement and it also needs to know what? So you guys remember what I said five seconds ago? Laura, sound, right. So it needs to know sound and then the noise level. And how does your phone pick up on sound in general, whether you're recording a video or however? What's the tool on your phone that does that? Mason? Microphone. Very good. Okay. So so these are just two more inputs that we can add on to this app. Once we have the app out there, it's successful, but we just want to make it a little bit better. And that's what we do during the reflect process. We just make the app a little bit better. So we're going to add on to our algorithm here. Okay, so if the phone is at school, okay, and yes, we are going to kind of add a different component here. Over here. And you guys can draw this however you want. I'm not it doesn't matter how the boxes and the lines are. It really doesn't. So if the phone is at school, what's the next thing we need to ask it? We need to first ask it, is the phone moving, right? Is the phone moving? Is the phone moving? Okay. So is the phone moving? And we also need to ask it, what's the other thing we need to ask it? Dominic, what else do we need to ask it? We need to ask it, is it moving? And yeah, or is it noisy? Is it noisy? And of course, there would be some type of, if we were actually programming an app, we would build in a specific decibel or, noise level into that. But we don't have to be that complicated right now. Okay, so we have to ask it two more questions. Is the phone moving and is it noisy? So what should happen if the phone is moving? What should actually happen? Mason? Yeah, we could turn the ringer back on, or the app should do nothing. So it should not silence anything. So either way is correct. Okay, either way is correct here. So we could say, big enough here, ringer turns on, do nothing. So the app does nothing or the ringer turns back on depending on, because when you walk into school, right, you're probably moving. You don't want You don't, when you walk through the doors in the morning, you're moving. You don't want your ringer to turn off just yet, right? Okay. So, and also, is it noisy? Whoops, I don't want a signature. What, why did I click that? Sorry, guys. So uh, if it's noisy, so if you're sitting down, you're not moving, but you're in the lunchroom and it's the phone's picking up on a certain decibel level, we also want to hear our notifications, right? So if it's noisy, yes, we want the ringer to turn back on and do nothing, okay? And do nothing. This is an algorithm. This is a drawn algorithm. And for your project, you'll make it a little bit prettier, a little bit more colorful, but this is your project and basically in a nutshell. So you're going to define a problem. You're going to think about what type of information that the app is going to need in order to work, where the app will get the information. Do you want to store it? And then you're going to think about the type of processing it's going to use and draw an algorithm that looks kind of like this, with kind of like yes, no type of things. And I forgot to put in my yes, no, but and then you're going to, test your output. You're actually going to create an app mock-up using an app called the Pop Prototyping app. It's pretty cool. It's not anything you have to program, but you're actually gonna like make your app, like make it the colors you want it to. You're gonna design an app icon, and then you're going to reflect and think about what could you build onto this app once the app is successful and doing well to make it better. So this is excellent practice for your project, which we're gonna discuss tomorrow in class all the details. I'm gonna show examples of projects if I can find them, and I'll give you guys a chance to think about an idea, but it's never too early to start thinking about you know what you guys want to do with your project. Since it is worth 100 points, we'll be working on it for about a week, week and a half. So, okay, so go ahead and turn in the ring silencer app. Thank you for everyone joining me on Zoom. I will catch you guys later.